So in this video, I'm going to be going over how to find the maximum or minimum value of a parabola by completing the square. So let's start off with an easy example. X squared plus 9x plus 25. So completing the square means you're going to turn this standard form parabola into a vertex form equation, which can be written as ax minus h squared plus k, and then using this we can find the vertex, which is located at h comma k, or k is where the maximum or minimum value is. So the first thing you're going to do is ensure that the a value in front of x squared is equal to 1. Since there's nothing in front of x squared, we know that this is equal to 1. We don't have to do anything else. You just put it in brackets, so x squared plus 9x plus 25. The next thing you're going to do, you're going to take this value, the b value from this equation, you're going to take it, and then you're going to divide it by 2, and then square it, which is equal to 20.25. Then you're going to put this into the brackets, so x squared plus 9x plus 20.25, and then minus 20.25. And then plus 25 at the end. Next, you're going to factor out the last number in your brackets. Since there's no a value in front, we don't have to multiply by anything to take it out. You just put it here. So now it's x squared plus 9x plus 20.25, and then plus 25 minus 20.25. And from here, we already have everything we need to find the maximum or minimum value. You just do this, 25 minus 20.25, which is equal to, which is equal to 4.75. That's here. In this case, it's the minimum value. Since it opens up, it would look like this. And then here is where 4.75 would be. But if you want to go a step further and fully complete the square, you have your perfect square trinomial here. So you're going to find the square root of 20.25, which is the last number in your brackets. So square root of 20.25 is equal to 4.5. So now this is all the same thing as x plus 4.5 squared, and then plus 4.75. And yeah, that's it. Now the square is fully completed. The vertex in this case would be located at negative 4.5, since this is x minus h, but since it's a plus value, it's negative 4.5 comma 4.75. So it's negative 4.5, 4.75. And that's it. All right, so now I'm going to go over a standard form equation which has a different a value at the front that isn't equal to 1. So let's do 4x squared plus 12x plus 27. So now, in this case, there's an extra step we have to do since a has an actual value that isn't equal to 1. So we're going to put the a value at the front, and then 4x squared, and then we're going to divide this by 4. So 12 divided by 4 is 3. So x squared plus 3 plus 27. All right, and now we're going to take this. So 3 divided by 2 squared, which is equal to, 3 divided by 2 squared, which is equal to 2.25. So now it's 4x squared plus 3x plus 2.25 minus 2.25 plus 27. So now we have to factor out the last number in the bracket, but now we also have to multiply that by the number that's in front, which, so negative 2.25 times 4 is equal to negative 9. So now this is equal to 4x squared plus 3x plus 2.25. Now we have our perfect square trinomial plus 27 minus 9. And as we know, this will be the minimum value of the parabola. 27 minus 9 is 18. So yeah, our minimum in this case would be 18. Or we can finish completing the square. So now we take the square root of 2.25, and that's equal to 1/2. Another thing you can do is just take the number 3 divided by 2, which is the same thing. You can do this for any time you're doing this. So now it's 4x plus 1.5 squared plus 18. So now your vertex is at negative 1.5 comma 18. So that should look like negative 1.5 and then 18. So x equals y equals, and that's it.